Welcome back, advanced topic students, to section 1.4, further applications. We're talking about linear equations here, and we're going to see how they're actually useful outside the classroom into the real world. Let's go ahead and get started. So who doesn't like money? Problems involving money. Now, how do we calculate the value if we have a bunch of money? And I pre-drew these. Okay, I add these in there, so if you want, you can go ahead. Clearly, these are coins. So if we're talking about coins specifically, that's kind of like the main one. Obviously, bills are a little bit easier. But if we're talking about coins specifically, how do we calculate, if you had like a piggy bank of coins, you dumped it in, how would we be able to calculate the value relatively quickly? Well, the first thing we need to know is we need to know the number of coins. So how many of each coin do you have? Now, besides the number of coins, we need to know the denomination. Are they pennies? Are they nickels? Are they dimes? Are they quarters? We need to know the denomination. Denomination is just an indication of what is the cent value on each coin. Now, once we do this, we multiply the two. Okay, and I'm going to kind of break that down why we do that in just a second. But we multiply the two, and we are going to get the total value of the coin. So we get the total value of coins. Now, the important thing is we have to separate it by denomination first. So we need to have like a sorting machine. Okay, so a sorting machine. We have to do that first. So anytime you have a machine, ATM, anything, what has to happen, there has to be a mechanism that sorts it. Otherwise, you're going to count dimes and pennies as the same, and they're not. Or quarters and nickels as the same, and they're not. Okay. So the first thing you need to do is sort, and that's why denomination is circled here. Now, how does this put into practice? Let's say we have 7 dimes. And we want to know the total value. Oh, well, obviously we know that's 70 cents, okay? We passed second grade, hopefully if you're watching this video. For all my second graders, hang in there. But let's say we have 7 dimes. How do we calculate the value? Well, first thing we have is 7. That's the number of coins we have. Now the denomination, we can't just write dimes. We're not going to multiply 7 times the word dimes. We need to have the value of a dime. What is the value of a dime? Don't put 10 cents, okay? Well, because we're going to get our total value of coins in cents. We want it in dollars. Okay, when we're talking about, no one says the stock market went up 35 cents. We say dollars. We do everything in terms of dollar value. So what is a dime worth in dollar value? Is worth $0.1. That's 10% of a dollar, 10 cents out of a dollar. And we're going to multiply that. Now, when we multiply those two things, what do we get? Well, we get 0.7. And this is dollars, 70 cents. This is another way of saying this is 70 cents. And that makes sense, okay? And this works with nickels, this works with quarters, this works with every denomination. So that's just a quick example why this particular formula, linear equation, works. Now, let's get into another example. For a bill totaling $5.65, a cashier received 25 coins consisting of nickels and quarters. How many of each did he receive? Now, this would be a great program on a cashier machine, whatever the mechanism, the box that the cashier is using, this would be a good program within the computer. So that's generally how it's used. But, I mean, knowing how to do this is useful because then you could know how to program it. So let's talk about the setup. The setup is going to be the number of coins. Okay, this is the general thing, number of coins. Then we want the denomination. Okay, and then we want the value. That's what we need. Now, the issue is we have 25 coins, and we know that they're nickels and quarters. Okay, we know that they're nickels and quarters. Let me put a box around this stuff. So we have a number of coins. Boom. Okay. Now, we need to separate out into nickels and quarters. So let's do this. We're going to copy and paste this box. Okay, let's be smart here. So we have number of nickels, and we're going to have number of quarters. Okay. All right, let's move this up. And we're going to put a box around denomination. Whoops. Hate it when it separates like that. Okay. Well, you know what? We're going to do this. Let's be smart. Copy, paste. Okay, copy, paste. There, and we have our value. Not that we need this, but, it's better to look a little bit more professional, right? Okay, so we have our setup. I know some of you probably triggered. Okay. And we have our quarters down here. We might need to make it a little smaller. Sorry about this. We'll do this, hold on. We're gonna copy and paste this first. This is a part you might want to skip ahead on, just FYI, okay? Not all of this you need to watch. I'm not that insecure. All right, so there we go. Close enough. All right, so number of nickels. Now, what are the number of nickels that we have? Guess what? We don't know. We don't know the number of nickels because all we know is we have total coins 25. That's all we know. So how do we figure out the number of nickels that we have? Well, what else do we know? We know that the value of the two, so the value of nickels plus the value of quarters is equal to what? Is equal to 565. So that's something that we know. That's useful information. Okay. Now, how do we relate the total coins into another equation? Because we need two equations here. Anytime you're dealing with a lot of unknowns, most of the time you need two equations to help you solve this. Anytime you have information, you want to be able to use all the information in its own equation. So if we have total number of coins, we want to use that as an equation. Total value, we want its own equation for that. So total coins, how do we do that? Well, we want the number of nickels plus the number of quarters equals 25. So what do we do here? Well, let me move this up. Okay, so we know that the number of quarters and the number of nickels add together will give us our total coins. So one thing we could do is we could say x plus y equals 25. Okay. Oops, I forgot the 5 on the 565. And this is total value. We could put x plus y, but the thing is, that doesn't really help us because we need to know, if we have two variables, that doesn't help us. So we need to be able to get x in terms of y. So what do I mean by that? Well, we could call the number of nickels x, okay? We could call the number of nickels x. So how do we find the number of quarters? Well, if we know that, let's just give an example. Let's say there's 5 nickels in this example. How many quarters would we have? Well, in order to find that, we know that the total adds up to 25. So we would do 25 minus 5 would equal the number of quarters. That would be 20. What did I do there? All I took was 25 and I subtracted the number of nickels. If we know there's only two types of coins, we can take the total minus one of the quarter types, one of the coins, and that will give us the other coin. Okay, this is a concept that we will use constantly in this course, but is one that's very difficult to understand for most people because it's a little foreign. Okay, you have to get a variable in terms of the other variable. So number of quarters, we don't want to just put y. We want to put 25 minus x because that gives us it in terms of x. We have the x there and the x there. We have everything in terms of one variable. That makes it a lot easier for us. Okay, now, before we said that the formula is times the denomination equals the value, times the denomination equals the value, okay? So one thing we need to know is we need to know the value of nickels. Well, we know the value of nickel is 0.05, it's 5 cents. And we know the value of quarters is 25 cents. Okay, so this is the quarter column, this is the nickel column, for those that didn't figure that out. So now we're gonna get all this together. Okay, if we know the number of nickels is x and we know the denomination is 0.05, we multiply the two and we should get 0.05x. That's our value. Okay, so we have the first piece of information. I'm going to put it over here. Our value is 0.05x. Okay, that's this bit. Let's move on to the quarters. So the number of quarters is 25 minus x. This is a key thing. This is the fundamental thing for this problem. If you can understand that you take the total number of coins, subtract the number of nickels to get the number of quarters, then the rest is fairly straightforward. So now to find the value, we multiply the two. So we do 0.25 parentheses 25 minus x. Okay, and we're going to write that value here. So 0.25 times 25 minus x. And we're going to add those two. Now we have an equation. Guess what? It's all in terms of one variable. So this becomes relatively easy. If you need, you can get a calculator. It shouldn't be that difficult, okay? But calculator is a good assist tool here. So we're going to have 0.25, but then we're going to distribute first. We're going to distribute first. So we get 0.05x plus 0.25 times 25, 0.25 times 25. That gives us 6.25. 6.25 minus 0.25x equals 565. We have like terms. We need to combine them. So we have 0.05 minus 0.25x, and we get negative 0.2x equals, and now we have to, well, actually, let's keep one step at a time. Let's not get carried away here. That's how mistakes happen. Line by line, everyone. 565. Now we're going to subtract 6.25 from both sides. So we get 6.25 minus 565, or actually the other way around. You guys know what I mean. And we get 0.6. Should have done that in my head. Shame on me. But it's negative. And we have negative 0.2x, which we need to divide negative 0.2 to both sides. Divide by negative 0.2. Negative divided by negative is a positive, and we get 3. What does that mean? Well, in our original problem, we defined x. X was equal to number of nickels. So x equals 3. 3 nickels. Now, how do we find our quarters? We just put in here 25 minus 3, and we get 22 quarters. So 22 quarters, sorry, that's a little confusing. 22 quarters, 3 nickels, that's our answer. Now I'm going to save this next problem for part 2 if you need another example on how to do these types of applications of linear equations, because this video is probably long enough. And I'll see you next time, hopefully soon. Hopefully right after you're done pausing this video.